From the monolithic, fossil-heavy grids of 1983 to the smart, decentralized energy networks of 2025, humanity's relationship with power has undergone a quiet revolution. For most of modern history, energy meant scarcity, scarce fuel, scarce transmission capacity, scarce resilience, and scarce access. The grid was built around giant plants, long wires, and one-way delivery. But today, solar fields, battery farms, digital controls, and millions of connected devices are turning that old model inside out. Power is no longer only generated in distant industrial zones. It is being stored, routed, predicted, and optimized in real time. But what lies ahead? Together, we have mapped the past. Now, let us look to the future. Over the next 50 years, we are not just transitioning our energy sources. We are mastering abundance. This is the story of the next half-century of power, as predicted by the world's leading engineers, scientists, and developers. Our journey begins with the immediate reconstruction of the grid itself. Between 2025 and 2040, the most important breakthroughs are not only about generating more electricity, they are about storing it longer, moving it farther, and controlling it with far greater precision. Early lithium batteries made the renewable age possible, but they were only the beginning. The next generation brings solid-state sodium-ion batteries, safer chemistries, lower material pressure, and longer useful life. Alongside them, long-duration iron, air, and flow batteries become the heavy foundations of renewable stability. They charge when the wind is strong and the sun is high, then release energy for days when the weather turns. At the same time, the transmission system is rebuilt for a continental and ocean-spanning age. Ultra-high voltage, direct current corridors connect deserts, coasts, offshore wind zones, and industrial centers. High-temperature superconducting cable systems reduce losses so dramatically that distance begins to matter less. Electricity can travel thousands of miles with extraordinary efficiency, turning the planet's best renewable zones into shared global assets. By 2040, the grid is no longer a fragile machine. It becomes an intelligent energy nervous system. By the mid-2040s, humanity steps beyond intermittent harvesting and enters a new nuclear dawn. The old image of nuclear power was defined by enormous custom projects, long construction delays, and political uncertainty. The next era looks very different. Factory-built small modular reactors, or SMRs, are designed to be repeatable, compact, and easier to deploy near the communities and industries that need firm, clean power. Some advanced designs use upcycled nuclear waste as fuel, reducing legacy stockpiles while producing reliable heat and electricity. These reactors do not replace renewables. They strengthen them. They provide a steady baseload foundation that keeps hospitals, data centers, factories, desalination plants, and dense cities running through every season. Then comes the breakthrough that engineers pursued for generations: commercial fusion. Inside magnetic confinement chambers, deuterium-tritium plasma is sustained at temperatures many times hotter than the core of the sun. The plasma never touches the walls. It is shaped, compressed, and controlled by powerful magnetic fields. When fusion finally feeds electricity into the global grid, the psychology of energy changes. Fuel becomes abundant. Carbon emissions fall faster. Nations begin planning not around shortage, but around what civilization can build when clean baseload power is always available. As we approach 2075, the energy system expands beyond the atmosphere. Space-based solar power becomes one of the great infrastructure projects of the century. In geostationary orbit, autonomous construction fleets assemble enormous golden collector satellites, kilometers wide, positioned where sunlight is almost constant. Unlike ground solar, these platforms do not face night, clouds, dust storms, or seasonal darkness. They harvest unfiltered solar energy 24 hours a day, then transmit it safely back to Earth through targeted microwave links received by vast antenna fields. On the surface, the grid itself becomes planetary. Artificial intelligence forecasts demand before it appears, balancing weather, industry, transport, storage, and orbital power in one coordinated system. Quantum-secured communications protect the network, while advanced sensors detect instability before humans would ever see it. Electricity moves through a unified architecture, that is fast, adaptive, and deeply resilient. The result is more than cheaper power. It is a new operating system for civilization. Remote regions gain reliable access. Megacities breathe cleaner air. Water can be desalinated at scale. Heavy industry can run without fossil combustion. By 2075, energy scarcity is no longer the central limit on human progress. The question becomes how wisely we use abundance. We are on the cusp of becoming a Type I civilization, capable of harnessing the full energetic potential of our planet and reaching beyond it. That future will not arrive automatically. It will require engineering discipline, public trust, smart regulation, resilient supply chains, and leaders who understand that energy is the foundation of security, prosperity, and human possibility. But the direction is clear. The future of power is bright, clean, intelligent, and limitless. Thank you for exploring this journey with me. Make sure to stay informed as the future unfolds. For more information, visit globalpowernews.com. Subscribe to my YouTube channel at Nawaz Lakho Power Pro. And do not forget to like and share.